I'm Supriya Lohar, working as an assistant professor at AISSMS Institute of Information Technology. I'm going to talk about directional coupler. Directional coupler is a 4-port waveguide junction, consists of the primary and secondary auxiliary waveguide. Directional coupler is a device that samples small amount of microwave power for the measurement purposes. The power measurement include incident power, reflected power, VSWR values. Let us consider schematic diagram of the directional coupler. As you can see, it's having a main primary waveguide and a secondary waveguide. So the difference between magic T and directional coupler is that magic T is hybrid or 3 dB coupler. It is an alternative to rat race coupler, whereas directional coupler, it will sample microwave power for the purpose of the measurement, whereas magic T is a 3 dB coupler. With match termination at all ports. Let us consider the properties of the ideal directional coupler. A portion of the power traveling from the port 1 to port 2 is coupled to the port 4 but not to the port 3. A portion of the power traveling from the port 2 to port 1 is coupled to the port 3 but not to the port 4. A portion of the incident power on the port 3 is coupled to the port 2 but not to the port 1, and the portion of the power incident on port 4 is coupled to port 1 but not to the port 2. Also, port 1 and port 3 are decoupled, same as the port 2 and port 4. So, let us consider different input and output powers for the directional coupler. PI is the incident power at the port 1, PR is incident power received power at the port 2, PF is the forward coupled power at port 4, and PB is back power at port 3. Let us consider the different performance parameters defined for the directional coupler. So first one is coupling factor. The coupling factor of a directional coupler is defined as the ratio of the incident power PR to the forward power PF measured in dB. So C is equal to 10 log of PI divided by PF. Next performance parameter is directivity D. Directivity is defined as the ratio of power PF to the back power PB expressed in dB. So D is equal to 10 log of PF by PB in dB. The coupling factor is a measure of how much incident power is being sampled, while directivity is measure of how well the directional coupler distinguishes between the forward and the reverse traveling powers. Third and the last performance parameter is isolation. So it is defined as the ratio of the incident power PI to the back power PB expressed in dB. So I is equal to 10 log of PI by PV in dB. It may be noted that isolation in dB equals to the coupling factor plus directivity. Thank you.